basing on this section, we are developing surfaces. Okay. So now we measure this one. This line will match with our offsetted surfaces. Say 0 mm. Okay. This edge will match with this surface. 0 mm. Like that, we need to analyze this and we need to develop the surface. That's the reason I'm saying, like ABC surface will not get any PPT. They will not mention any thickness. They will give master section and the surface. You need to develop part accordingly. Okay, here we need to take how much thickness also from master section itself. Okay, so from master section we have measured that thickness is 1.5. So we are offsetted 1.5 now. On which side you will be offsetting now? Amit, if you are following
Outside.
master section, you can able to understand easily.
Yes, sir. It's in outside of the body surface.
Yeah, we are taking inside actually. See, this surface represent this boundary represent this surface section. We are developing this line, right? It is going inside. So this surface matches this boundary. Okay, this section, not boundary, this section. Actually, we need to call it as a section.
Okay,
Okay,
sir.
so first of all, you practice for some of the components. Okay, like now I shown you right what Vidyasagar had done. Like that, you able to make the sections for some components. Okay, so then you can able to understand what is that. Okay, how the sections are forming. Okay, that's the reason yesterday I given small task for everyone. So now we are going to develop C surface. Okay, first we'll close this body. This is one view. So here, I think everything is in line. Okay, you need to check the dimension first of all. For everything you go, you need to check everything with master section only. See this line and this line. This may have distance, but in Z you can see it's 0.9 all that. Okay, 0.9 means it's like negligible. Okay, there may be some distance. Okay, but it's taking diagonally. Whatever the distance is there, it's taking diagonally. Okay, you can see here that the measurement is diagonal. So don't take that, okay? Take whatever the compass is aligned. You can see the compass, Z direction. See the component wise, will be having 0 point Z direction. Means there is no much difference in the height between this edge and this edge. Okay, so what I will do, I will close this A surface, okay? Means I'll fill this one. So now I'll check this, okay? Surface is matching with our section or not. So edge and surface exactly matching this surface. Okay, and surface this is also exactly matching. Okay, so this is the surface we are getting. So now we will be trimming all this in final join. Okay, uh, in the same way what you're doing in ABC concept, the C structure will be remaining same. Okay, so this surface.
Sir, I have a doubt, sir.
Yeah.
Sir, can we use fill operation here?
Yeah, we can use this. Sorry, Vidyasagar, right?
Yes, sir. Yes, sir.
Yeah. Here we can use the fill operation. Okay, this is only the small part. Okay, this is not the actual automotive component. Okay, this
Okay,
is for a study purpose.
Okay, sir.
So now this section is matching with this surface, the closed surface bottom. Okay, so everything is matching now. You can see. Okay, showing this section, but in this surface we have seen that. Now I'll close this body. Okay, this is how body. Now we are developing these features. Okay, the internal features, how it will be. We are developing this in the internal features. Okay, so I'll do power copy for one. Okay, and I'll impact replicate others in just using power copy. Okay, so for one I'll do power copy. For doing this, we need to take some reference points. Okay, and I'll take center of this circle. Here they have given tooling direction also. Okay. So I'll isolate this. I'll do quadrants. Let's take an axis system. We need to check this plane is aligning with this circle or not, first of all. Okay. So first I'll take this line. See, it's 0 and okay, it's exactly aligned. It means there is no distance for this. Okay. Otherwise, you can use the same circle if you have any difference. Okay, you can use the same circle. When you do power copy, right? When you want to edit the circle diameter, then we may not be able to do that. So we need to have clarity. See here, the plane is deviated with some angle here, 172.933 degrees. That means almost 8 degrees. No, 7.1 degree angle is there. So we will be aligning this with any of these lines. Okay. X I'll be aligning with this line and Y I'll be aligning this one. Okay. So now we can check whether it is aligned or not. Select no selection. Y is coming back again. So X will be in this direction. Okay. And Y will be in this direction. Or just we can see the angle first of all, later we can use no selection. And edge, you can see 0 degree now. Okay, 0 mm and 0 degree. Now our axis system is exactly aligned and we need to remove the links now. So I'll remove the links, no selection. It's changed actually. We can check whether it's having same angle or not. It's same angle. Okay, 180 means it's nothing but parallel. Okay, so everything is aligned now. Now I'll sketch it here. I'll take another body. So match this circle diameter. So measure this circle diameter. 10 mm diameter. Okay. Exactly, we measured it. So for a while, I'll off this master section. Okay, because I don't want to touch any other edge. So I'll extrude this one till bottom. Then the top should not be increased because that is our limit. Okay. Prior to this, I forgot one thing. We need to do draft analysis. It's a small component. That's the reason we have not done draft analysis, but we need to do draft analysis as we have done like ABC surface. Primary, we need to do draft analysis for A surface. Okay. Next, after closing the body, we need to do one more draft analysis. Okay. So if you want you guys to do now, or you are aware, right? Okay, shall I continue?
Yes,
with
sir.
so this is
It's
the,
okay, sir.
okay, this is the tooling direction. We need to do accordingly with this.
Yes, sir.
Now, whatever we have drawn, right, the circle, the X2 portion is everything is not matching. You can see here, it is deviated. Okay, this is matching, this is matching, this is matching. Other if you have doubt, so you can check it with this option, measure and this. Okay, you can see 0.036. That is final. Okay, don't touch this word. Means don't try to match exactly. Okay, it may be very small amount may be varied. Okay, like 0.0. After 0, you can neglect this one. If you have anything different like 0.1, then you need to take care. Okay, and you can see this edge as well. Okay, so but this edge you can see there is a lot of difference here. This edge, see there is difference of 22 degrees of angle. Okay, see here it is drafted. You can see the tooling direction. Okay, and this one. Okay, so this is drafted actually. That's the reason it is getting elongated here at this area. So we can see the draft angle how much they are given. So guys, be cautious here. Okay, check the draft angle properly. Here you need to check draft angle with the master section and the tooling direction given, not with your body. Okay, so edge and edge you keep it. Only one line you can touch it, and you can see 178 degree. 178 degree is nothing but your draft is 2 degree. Okay, don't give 178 degree draft. It will not take. Okay, only up to 90 degrees only will draft will be taking generally. Okay, even not 90 also, or 89.5 or 89.9 up. So there only the draft generally command will work here. Okay, here the draft it's 178 means 2 degree. Okay, parallel means 180 degree, right? So 180 minus 178 is 2 degree. So that's the how we will be taking. Okay, generally we'll be get 2 degree. You can check in others also here. Same like so this edge. See here you got exactly 2 degree. So the sectors will be there, right? Sector 1, sector 2, sector 3 in circle. Sorry, not in circle. The graph, okay. So in that way you need to you need to analyze. Okay. So 178 degree means you have 2 degree of draft. So let's see, we'll give 2 degree of draft and we'll check it. Circle for this draft. Okay. Neutral element will be top one because the circle is we have taken from exact dimension. This is the one. And the pulling direction will be our distooling direction. Okay. So now we check 2 degree of draft into given. Okay. Check that value also. Here 2 degree of angle should be given. You can see here. Okay. So now we can check the value. It's exactly 0 mm now. Okay. It's exactly matching now. Okay. But here thickness, you can see here the thickness is not equal here. As I shown you earlier, there is 1 mm thickness over here. So you can see the thickness. See 1 mm thickness here. So you need to have only 1 mm thickness. Means